So when we look at the branch configuration, we definitely are going to go to that interface and say IPv6 OSPF, specify the process ID, and make sure that it's in the exact same area as we had over on HQ's gigabit 0/1 interface, because if it's not, we won't form our neighbor adjacencies. So let's take a moment here. What has to match to form a neighbor adjacency? Well, number one, we have to make sure that the area number matches between the interfaces that are going to be forming the neighbor adjacency. So these interfaces have to be in the exact same area. What else has to match? Well, just like with OSPFv2, timers have to match. So let's not forget about those timers matching between those interfaces. By default, we have a hello timer of 10, a dead interval of 40, but we can configure those on an interface by interface basis. So if you do change it on one router, make sure you change it on the other router as well to make sure that they are the exact same, or you won't form a neighbor adjacency. If we're using authentication parameters have to match. If we are creating some type of stub area or totally stubby area, those stub area flags have to match as well in order to form a neighbor adjacency. MTU has to match here as well. What about subnet? Do we have to be on the same subnet? Take a moment and think about that. Look at this. We are on the same global unicast subnet here. 2001, DB8, D1A5, C900 /64. Yeah, we're in the same global unicast subnet, but do we have to be to form a neighbor adjacency with IPv6? No, we don't have to be. We don't have to be at all. Now, why is that? Because we form neighbor adjacencies with what type of address? Do you remember what the type of address is? Link local. Link local addresses. So if we're forming neighbor adjacencies with link local addresses, the global addresses don't matter when it comes to forming a neighbor adjacency. We could be in completely different global unicast subnets and still form a neighbor adjacency because based on link local addressing, we are in the exact same link local network. And that's what matters here. That's what matters here. So you could form neighbor adjacencies with OSPF without even having global unicast addresses on interfaces. So long as you have a link local address, the interface is enabled for IPv6, you could form a neighbor adjacency between these two routers without a problem. And this interface with a global address, that network can be advertised over to HQ without a problem. Without a problem. Because we have a neighbor adjacency, and I'm just sharing that global information using OSPFv3. Let's look at some of the other options we have in here. As I said before, when you're creating your OSPFv3 process, that doesn't have to match. So the process ID could be completely different between the routers, and that would be fine. What matters is that this value here matches this value here and this value here locally on the router. So it's locally significant. The router ID has been manually specified here with 2.2.2.2 on branch. Notice they're giving us an example of the passive interface command. We're making loopback 0 a passive interface. Why? Because we don't want to send any hello packets at that particular interface, but it's a loopback interface in this example. So it really doesn't matter if we make it passive. But if I was a gigabit interface, a serial interface, or any type of physical interface where we could potentially send hello packets out of and they be captured, or some other router have the ability to form a neighbor adjacency with branch at that interface, because we're sending hello packets, making that interface passive like we did with OSPFv2 would be very important. And then down here they're showing us, let's enable loopback 0 for the OSPF99 process and place it in what? Area 1. Area 1. So that's what's making this router an area border router. We have this interface in area 1. We have this interface in area 0.